Hello, my name is Dawid Żywczak. I am software engineer here at TypeScript AI, and I'm joined today by
Jakub Duda, and I'm software engineer and TypeScript AI.
And today we will be talking about T3 Stack, which is a modern full stack development framework, simplifying development of applications. So let's go through the agenda for today. First, we will have some overview of the stack, along with presentation of its core components. And then Kuba will present a demo of the application that we've created, along with code walkthrough and some live coding. So what is T3 Stack? As you can see here, it's the best way to set up an opinionated full stack type-safe Next.js project. Which means that this is a modern web development framework designed to streamline the process of building full stack applications with a focus on performance, scalability, and developer experience. It emphasizes end-to-end type safety, ensuring that code remains consistent and reliable across the entire stack. By combining cutting-edge tools for server-side rendering, database management, and seamless communication between client and the server, the T3 Stack provides a cohesive and efficient workflow for developers. Its modular design allows us to build robust applications while maintaining flexibility to adapt to specific project requirements. This stack is particularly valued for its ability to ensure clean, maintainable, and scalable code for full-stack applications. The stack follows three axioms, which are solve problems, which means that every tool or feature included in the stack is added to address specific real-world problems within the core technologies. Bleed responsibly, which means that while we embrace cutting-edge technologies for innovation and speed, the stack is cautious about where risks are taken. Riskier technologies are adopted in safer areas, ensuring stability for critical components, like, for example, databases, while exploring new tools like tRPC, where transitions are simple. And the third axiom is type safety isn't optional, which means that type safety is not negotiable, as it improves productivity and reduces bugs. So now let's talk about main components of the stack. First and the most important one is Next.js, which is a React-based framework that enhances the development of modern web applications by providing built-in features like server-side rendering for improved CEO, for example, static site generation, and API routing. It simplifies complex tasks like creating dynamic routes, handling server-side logic, and optimizing performance, making it an excellent choice for full-stack development. In this stack, Next.js serves as the foundation for building the front-end and the back-end. It manages the structure of the application, handles server-side logic, and facilitates seamless integration of APIs. This allows developers to create highly performant applications with features like mentioned pre-rendering for improved CEO and fast load times. Its integration with TypeScript and tRPC ensures type-safe communication between client and the server. Next, we have TypeScript with some nice showcase of the language's capabilities, which is a statically typed superset of JavaScript that introduces types annotations to improve code safety and maintainability. It catches errors at compile time rather than runtime, providing developers with better tools for debugging and reducing the likelihood of bugs in the codebase. Additionally, TypeScript enhances development workflows with features like intelligent code completion, refactoring tools, and detailed documentation generation. In the T3 stack, TypeScript plays a central role by ensuring end-to-end type safety across the entire application. It allows developers to define types for components, APIs, and database queries, creating a consistent and reliable development environment. Next, we have Tailwind CSS. You can see the code using Tailwind on the left. The text colored orange are the Tailwind classes. And Tailwind is a utility-first CSS framework that provides pre-designed classes, which you can see here, to style web applications directly in your HTML or JSX. Instead of writing custom CSS or relying heavily on predefined component libraries, Tailwind lets developers build unique, responsive designs quickly using composable atomic utility classes. It promotes consistency and reduces CSS bloat by encouraging the reuse of these utilities. In the T3 stack, Tailwind serves as the powerful styling tool for creating modern, responsive, and aesthetically pleasing user interfaces. Its utility-based approach aligns well with the stack's focus on developer productivity, enabling rapid prototyping and reducing the need for context switching between CSS files and the components. Next, we have Prisma, which is a modern object relational mapping tool designed to simplify database interactions. It provides a type-safe and intuitive way to define database schemas, run queries, and manage migrations. Prisma generates TypeScript-based models that ensure consistency and error checking when interacting with the database, making it easier to write reliable and maintainable code. In the stack, Prisma is the bridge between the application and the database. It handles database access efficiently, allowing us to define and query data using declarative syntax. Its type safety aligns perfectly with the stack's focus on end-to-end type consistency, ensuring that data models remain in sync across the stack. Prisma's migration tools also simplify evolving the database schema, enabling seamless updates without compromising data integrity. Next, we have mentioned earlier tRPC, which is a modern framework for building type-safe APIs using TypeScript. It allows developers to define APIs and their client-side counterparts in a single code base, ensuring end-to-end type safety, again, without needing REST or GraphQL schemas. With tRPC, server-side logic is exposed as remote procedure calls, as in the name, enabling seamless communication between the client and server while leveraging TypeScript's strong typing for error-free integrations. In the stack, tRPC acts as the glue that connects the frontend and the backend with complete type safety. Developers can define API routes in a centralized manner, and the types automatically propagate to the client, ensuring accurate data structures and eliminating mismatches. Last but not least, we have NextAuth.js, which might be considered as an optional component for the stack, but it's very useful because it's a flexible authentication library specifically designed for applications built with Next.js. It simplifies adding secure and robust authentication by providing built-in support for various methods, including OAuth providers like Google or Facebook, as you can see in the example configuration on the left. And also supports custom authentication mechanisms. NextAuth.js manages session handling, token generation, and user management, allowing us to focus on application-specific logic rather than building yet another authentication flow from scratch. In the T3 stack, NextAuth.js is commonly used to handle user authentication and session management. It integrates seamlessly with Next.js, leveraging its API routes for server-side logic and providing easy-to-use hooks for accessing authentication states on the client. This makes it a powerful tool for creating secure full-stack applications with minimal setup. So this wraps up our introduction, more technology and theory-oriented part of the deep talk. Now Kuba will walk you through the demo application along with its code, and he will also add some features with you.
Thanks, Dawid. So let me share my screen. And at the beginning, we are going to go through our demo app. It will be a simple app, but showing the capabilities of T3 stack. So the first, you can see that we have sign in button, and we provided the authentication using NextAuth and logging with the Google provider. So as you can see, now I logged with my company email, and you could see that when I was not logged in, there was only in navigation the dashboard button, and now the root images is available. This is the root that is protected with authentication. We already have some image generated, so let's generate another image. So let it be maybe sleeping dog. And what is going on now under the hood? The image is created in database, and the Python process is run in the background, which will generate an image using OpenAI API. And after the image will be generated, it will be updated in our database. And as you can see, data refetched, and we can see image. So let's jump to the code, and let me go through the directories which are in repository. So the first directory is Prisma, and it contains migrations for database and schema. In Prisma, as you can see, there is already a prepared schema for the question we will be adding later on. The public directory is make it bigger. Okay. Like that will be good, or okay. So the model for the question will be adding it later on. The public directory is our Next.js public directory for serving the static files like images, fonts. For now, we have here our DeepSense logo. The scripts is our custom directory, and we store here Python scripts for generating image and answering the questions. And the SRC directory, it contains the whole application backend and frontend in Next.js. So the app is the Next.js app router. This is a routing system introduced in Next 13. The server directory stores the backend specific logic, So we have here the API, and we have router here. So image and question. Styles, this is directory for host for styles. CSS, some configuration for Tailwind, or maybe styles that will be used globally in our application, and tRPC directory, where we have configuration files for tRPC. So let's now back to the live coding, and we are going to add a new route for our application with capability to ask questions and get answer from OpenAI API. So I already have prepared the variable. This is the array which contains our roots. So here will be our root. It will be called /chats. In the next step, we are going to add a new root and create methods for calling API. So in question, we need to create 3 endpoints for getting all images, and this will be the root protected by authorization. Create a new question. This will be also the root protected by authorization, and the final will be updating the question, and this will be a public root because this script currently does not have any authentication. So for creating the endpoint for getting all images, we are going to create get all, and it will be protected procedure. The parameter, this will be async function as parameter. From the context, we can read our user ID. And as you can see, we got fully typed completions. So we are going to return from our database all of the questions were created by ID. Field will be our user ID. And we would like to order by created at and from newest to oldest, so descending. For creating a new question, this will be a bit more complex, so let me copy and I will go through the code. So the create a new question is also just right now. This is also the protected procedure, and as input we have ZOT validation, so the question is a required field. In the mutation, we create a new question, and later on we spawn a Python process where we pass the question ID, we pass our question, and callback URL on which the Python process will be later on will call an update method. So right now, let's write down the update method, and this will be different because it will be public procedure. So, oops, sorry. Oops. This will be sorry, I just lost myself. Okay. This also will have the validation for the input. So it will have set object, and it needs to have ID, which will be string, and it will be UID type. And what update method requires, it will be an answer. So set string, and answer, let's say, must contains at least one character. Either way, answer cannot be empty. Yes. So let me copy a mutation method and also go through it. So we check if question exists. If not, then we throw a new error and we update our question in database. In case our root is available in code, so, we need to have it in our tRPC router. As you can see, it is already there. So let's now add some logic for reading data from database in our UI code. I already have prepared the UI for displaying the questions list and answers, and also the field for writing down an question. So now let's write down how we receive our data. So our data is received from API by question, get all method, use query, and as options, we can add that this data will be refetched in some interval. So let's say it will be refetched in every 3 seconds. Also, this receives returns is loading variable, so we can display any loaders during the fetching and refetch method. So let me also copy and go through the submit function and write down the create question method. So one more time, we're gonna use our API method question with create method, And this time we're going to use mutation instead of use query. And right now our handle submit should work. Of course, the data should be questions. And now hopefully everything should work. So let's jump back to the something is that. Let me find where's the bug. Question public procedure query. It might the server is stuck, so let me restart dev server for application. Okay, and as you can see, there is already some questions in our database. Let's ask for different capital of different country. So let's say Canada, and let's wait and see if we are gonna get an answer. Hopefully, yes. And we got our answer. So Ottawa is the capital of Canada. So thank you very much. And Dawid, let's back to you.
Okay, so I just want to share you a thank you screen, as we would like to thank you for your time today, as this marks the end of today's Deep Talk. Thank you, Kuba, and thank you all.